Hello and welcome back to the Poor Man's Electronics Bench, episode 005, part 2. In this episode I will cover taking voltage readings on the two transformers in the unit to check for proper functionality before continuing with work. And a bonus device inspection will be revealed in all of its used goodness. This episode will involve working with 120 volt AC line voltages and AC peak-to-peak voltages up to 1400 volts, which can shock, injure, or possibly kill you. If you work on a unit like this, please take the proper care and safety measures required. I hope you enjoy the video. Hello and welcome back to Poor Man's Electronics Bench. This is part 2 of my episode for the Eico Model 434 Semiconductor Curve Tracer. And in this episode I'm going to go over just testing the functionality of the transformers in the unit to make sure that they're working properly before I can proceed making all my further repairs and component replacements. And in doing so, I am hooked up to a isolation transformer and a dim bulb tester. Both of these units are off camera a little bit and give you a quick view of them, but they're my own homebrew creation. And the isolation transformer has its own meter, breaker, its own output level meter on it, and a cooling fan inside. And my dim bulb tester is a contraption I brewed up over the summer. It's got a lot of functionality to it that I liked. It's switchable for bulb outputs for current limiting up to 400 watts. Plus it has a voltage measurement meter for the actual outlet power voltage, switches to select the bulbs, 3 selectable levels of circuit breaker power inputs, which can be either run individually or in parallel to go up to 15 amps, a ground fault outlet. I have the device outlet, which I can also reverse polarity on without pulling the plug out of and making any funny connections, in order to just check a device to see if it's got a hot chassis or not on either side of the polarity really quick, or if there's other hum issues that might be mediated by reversing the polarity. And then also I have a selectable 2-input power where I can have an isolation transformer and a direct AC line input to the unit in case I need to go direct line and not have the isolation transformer in series. So that's the functions on it. Right now I'm going to be running things through the isolation transformer, and I have an old sacrificial meter. I'm using a meter that I don't normally use. It's an older Fluke. It's being used because I'm not sure of the actual AC voltage output of that transformer. It's rated at 1000 volts, but I think that might be the peak voltage, 1000 or 1400 volts. And I'm not willing to connect a regular meter to it until a regular higher price meter to it until I figure out what voltage it might be. If this one overloads, I can possibly go to a meter with a higher rating or introduce a high voltage probe into the testing. But in the meantime, we're going to use this meter. I'm checking it. It's got a line voltage. If I go direct and bypass my dim bulb setups, I have 123 volts coming into my dim bulb panel. The meter is indicating 122, so I know it's got a good AC function on it. So right now I am limiting things at a 7 watt, with a 7 watt bulb. It's a very, very low level. It's basically just to kind of check for signs of life. So I'm going to disconnect the meter from the AC output of the dim bulb tester. And I'm going to start off by testing the low voltage transformer. There's 2 transformers in this unit. One's a low voltage. I think it's only maybe 6 volt, 12 volt AC output. We're going to check that level for sure. Got my power switch is currently off on the equipment. I'm going to roll a tape in here to level things out a little bit because it's wobbling around a lot. And I'm just going to check the secondary voltage on that transformer. I did check the fuse. The fuse is of a proper reading and not blown. And it looks like the black wiring is going to the primary, so I'm going to hook up and depower things first. Make sure I'm depowered. I am plugged in, but I'll make sure I'm depowered first. I'm going to hook up to the secondary of the lower voltage transformer just to check its output when I turn it on. I can document the voltage level on it. Okay, so I should be hooked up. I'm on AC volts with a 600 volt max, I believe. And going to power up dim bulb tester. I am going to turn the power switch to the unit on. To give it a little less than the dim bulb limiting. I have a 40 watt bulb in. I have 120 ohm volts at the outlet. I'm going to go a little higher. No, there might be, I might need to rotate some switches in order for this to work, and or there is a, no, I might have it in the wrong setting for this function to work. Let me double check something here. Okay, there we go. I was in the reverse peak inverse voltage setting before. We are down to 7.45 volts AC on that transformer. It can't. That transformer only works when the majority of the settings are in the function positions are in anything but the reverse voltage setting. So at this point, I'm going to turn the unit off. I'm going to try to set up to read the high voltage transformer output at this point. I found they've had to do some research and tinkering with this thing. I found that this only has an output on it when the push button for peak inverse voltage is selected on the front of the panel. It is depowered until then. I'm going to make all my connections one-handed, one at a time. And now I am going to turn the unit back on. And then I'm going to energize that transformer, hopefully with the peak inverse voltage button. And oh, we are indicating a 1000 volt AC voltage, even though it is only, this meter is only rated to 750 volts AC. It's indicating 1000 AC volts, which is really interesting. Going to go off. That's so meter survived, and apparently the transformer's functioning as it's supposed to. There's no smoke or fumes or blown fuses or anything. So going forward, I'm going to think that it's a successful unit to work on. This particular unit, like I said, it looks to be a factory wired unit. These were available in kit form, and the factory unit has its own. It has a serial number marking on the bottom removable panel of the chassis, as well as that. And if you notice, things are nicely tie wrapped. The wiring's nicely routed. It looks like somebody qualified with a knowledge of the equipment from experience in assembling a lot of them did the work here. So this looks to be a good unit to go forward with doing a recap on it and then evaluate it for its performance and adjust it if properly, if necessary, I mean. And we're going to depower it. So I'm going to document those voltages. I did find a manual information online with this, with a schematic. Although the schematic was hacked up into 3 different sections, I ended up reconnecting the schematic diagram into one diagram that can be printed off on an 11 by 17 or larger. I cleaned up a lot of the graphic information on it as far as the values, double checked things, and made sure that it matched the parts list and it looks to be a lot more usable documentation. What I'm going to end up doing is documenting my winding resistances on the transformers and then also the outputs, and placing them on that. And going forward, as I'm going through the unit, I'll probably also take voltage readings on certain components, place them on that schematic, and then once I'm done with all that, I plan to upload it. I think I got it from Boat Anchor Manual Archive site, and I'll probably upload that back up on there, so anybody that needs that information in the future, if you run across one of these units and need to work on it, will have a good, accurate documentation of a schematic with values on it, which is really helpful for working on any old equipment. So at this point, I'm going to clear off this item and introduce you to the next item to work on. I have decided to give you a treat for examining another one of these units. What happened was I ended up seeing another one come up on eBay for a reasonable cost as well. They're actually coming up a lot cheaper than the B&K 501s and the Heathkit 1121s and 3121s, and identical unit. This one's a bit more worse for wear and tear though. It's missing all of its little silver caps on the knobs. I can probably just clean the glue off them and it wouldn't be too bad. But remember I was saying in the first part of the inspection to do a shake and rattle test? Doesn't sound too good, does it? We're going to open this guy up and see how bad it is. It does have a fuse, and surprisingly, amazingly, the fuse is not blown. But this and different screws than the other unit. This one I do not see a serial number marking on. Small sticker on the bottom like the other one, so there. And then we're missing a screw, so odds are there was some tomfoolery and shenanigans that went down inside this one. This is kind of like a bonus feature. The fact that things are clunking around inside of it does not bode well. I have to. It arrived recently, and I just have to see if this one was marked as. I forgot if this one was marked as parts. Parts are just used. If it was marked as just used, then there's a lot of things damaged inside. This one might be a return, because used means something that's in working condition on eBay. I'm sorry. Oh, this is going to be quite the reveal here. Oh, okay. Not much of a residue of anything on the bottom of the panel. And right now it looks like the main offenders are just the hardware on the transformer. I can probably go over the voltage readings on this as well, especially now that I know what to account for. It looks like the power cord is in fairly decent shape. No weak spots on the insulation. This board is different. It has a different capacitor layout. To it, so there was probably some upgrading, and here's another reason why you don't just take stuff and plug it in. One of the hardware nuts for the transformer is just stuck to the board. I'm gonna try to round up everything that was floating around inside of it before I proceed any further. For its entertainment value alone, it was worth getting this guy out. So there's one nut. There's two nuts. Now I am also expecting a couple of lock washers. Oh, actually, we're missing the mounting hardware on both transformers. Oh no, there's the one. There is a screw, a flat-headed screw that came out of something. From the looks of it, these... Okay, that's odd. I should have another screw on the outside of that panel. Oh, that's a machine screw. Like a 632. That was probably the screw that mounted the transformer in from the outside. I don't know how it got inside the unit. Looks like it goes into that hole fairly well, but probably remount those with some lock washers. Yeah, that's exactly what it is. Sorry about that. That's exactly what it is. That screw. The missing screw off of this transformer. One of them was somehow worked its way inside the cabinet, even though it was should have been exposed on the bottom. I just want to take this guy and give it a vigorous shake, and it doesn't feel like anything else was loose. So this is, as far as the board's concerned, this one board, it's definitely a newer version of. Doesn't look like anybody's been poking around in here either. Oh, there's another something that happened on the way here. This one's got a broken terminal strip. It's let me get some lighting here. This terminal strip was probably mounted on the hole for the transformer. And what happened was when the hardware came loose, that transformer knocked around enough to crack it. So, and hard to say whether that mounting terminal was also being used as a ground, but it looks like it was because one of the leads for the power cord was going there, so I'm going to have to source a 5-position terminal strip. Replace that with, I also, the neon lamp wires are also on that board, so it's going to be some careful rearranging and repair. This is interesting because somebody, I don't know if you can see this on the strain relief, things are actually dancing around in here so bad that at one time the strain relief was crimped onto one spot in the cable, and now it's in a different spot. I think I'm just going to do a continuity test on the transformer windings now until I can source a board. But yes, that's a 5-position with the center mounter as a ground. And I guess the one thing that didn't change was the quality of some of the parts. They have the same type of rheostat. You can see that. Okay, with the spring-loaded wiper. So luckily the damage was contained to just that one terminal strip, but always be aware, there are people that tell you to check the knobs and everything. Well, if you can do that before you own it, or have the owner do it while you're watching it, that's fine. They still own it. Oh, wait, here's the other screw. Yeah, if you can do, if the owner can do it with you witnessing it, that's fine. He still owns it. If you do that, especially if it's plugged in afterwards, you saw where the one nut was that ended up in that printed circuit board. There's, Lord knows if there's loose or missing parts inside, what can happen when that thing is plugged in and powered up. And that's why it's always good to make a thorough visual inspection of what's going on the inside of any unit when you receive it before you even go through the process of asking yourself, does this knob work, and does this turn, and does this switch do this? So, some of the soldering It looks to be a little bit more disheveled inside this chassis. There's some spots where point-to-point wiring was worked pretty close, and oh, I see a wire to nowhere as well, so we'll have to investigate that. I was just noticing a couple of things. There's one spot where we have I'm going to go off the camera cradle here. I was noticing this area here had some wiring that left a little bit to be desired for quality. It looked like somebody was in a hurry. They ended up melting insulation on one wire, trying to get another one on the area, and then we have a yellow wire going to nowhere. It's looking like it either was never soldered, or I mean, I don't see any evidence of tin or solder on that wire at all. And I don't think these were kits. I didn't see, there's, the manual does not appear to show it as a kit configuration, so I'll show you a little closer view of that cracked board there. It's cracked right just under the third lead, and those two thin wires are just leads going to the neon power lamp. So, like I said, it looks like the damage was contained just to that area, thankfully, and besides that, and figuring out where that wire was supposed to go to. In the course of doing things, I'm going to plan on recapping this one as well, and the nice thing about having two units of the same make and model is you just order more of the same parts. Let me just take a visual. Well, it's hard to see again because they went. It's got to be the same. Well, I shouldn't say it's got to be the same capacitors. Well, I might have to go through the process of lifting them out of the board to see what they are. So that'll before I make an order, an erroneous order, that would be a good thing to do. But in the meantime, like I said, I'm going to take some measurements on the transformer windings. Be a smart thing to do going forward. I'm going to guess for the most part that they have continuity. But verifying them would be my best interest. This one was fairly low because this was the 6-volt winding. Half of an ohm. Let's see what the primary is. Boy, again, 87 on the primary on that one. See if this, out of curiosity, let's see if that red wire ends up coming to the same area. Maybe not, but no, that's not crucial. This one had a fairly high resistance, 3.6K. And then this one there, and the other one is on the rheostat. And that's 9.6K for the primary of the high voltage transformer. So there's no obvious component damage as far as anything being burned out, fried, exploded. So we're going to think that this one's also a good candidate to apply some work to get it back into a good quality working service. So after this, we'll just going to work on making my capacitor order. I chose to not bore you with the details of ordering the capacitors for these devices, so I will leave you with the information that I will be planning to order those capacitors and start to work to get these devices back into a good working testable condition, at which time I'll hook them up to an oscilloscope and try to actually display some functionality on them. So in the meantime, I thank you for viewing this video. There will be another part to come soon, and I hope that you enjoyed this content and will return in the future for more content just like it. Thank you. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.